What's up, everybody? Welcome to week 10. We only got three more weeks left of this trimester. So I'm going to talk about a couple of things as we start this, or before we even start notes. So last week, guys, we got all the way through thermoclines and salinity. So we kind of talked about how the temperature of the ocean is changing depths, and how that's actually affecting the temperature. So like I told you before, guys, we're going to take like 2 days of what you would probably call boring notes, just to give us more of a well-rounded idea of what the heck the ocean is and what are some things going and doing with it. So we at least have some type of idea. Now, with that being said, today we're going to talk about how does the ocean affect our climate. But before that, I want to guys just mention a couple things to make sure we're all on the same page. So on Google Classroom today, I did send you guys a link to a reading. I highly recommend you guys read it. We're going to discuss it on Thursday and Friday for the students that are going to come in school. So the House B students, we're going to discuss it on Thursday and Friday. House A students, we're going to read it today in class and kind of discuss it then. But that reading is pretty interesting. It's pretty new. And some of the things that they talk about in there relate to the ocean and relate to biology and relate to environmental science. Now, is it pretty sweet stuff? For sure. And a lot of you guys like penguins, and it's about penguins. So maybe you should go and read it. Okay. Now, without further ado, let's get to this. I'll make a couple announcements at the end. This will make up the rest of you guys' day for Monday for me. So it says, how does the ocean affect our climate? So the ocean is an important factor in the global climate because it collects and moves water, heat, and carbon dioxide. So remember, guys, the ocean is 70% of the world. So whatever that it's going to, or how did I word this? My bad. 70% of the world. So whatever happens with that 70% is probably going to affect the other 30%. So the components are consistently exchanged between the atmosphere and the hydrosphere, so between water and earth. And as things evaporate, water goes from the hydrosphere to the atmosphere. So remember, if we pour out water on the ground, it will evaporate. Now 70% of our planet is water, so there's a lot of evaporation occurring. So because the ocean can store so much heat, seasons occur later than they would, and air above the ocean is warmed. So remember, you guys, when we talked about on Friday, the ocean has a high specific heat, meaning that it takes a lot of energy to actually change it by a couple degrees. So we kind of made the comparison, like if your body temperature is at 98.6 and then it increased by 3 degrees, now you're at 101.6 and you don't feel really good. So when people look at this in the ocean, they're like, it's only 3 degrees, it's fine. But realistically, 3 degrees is a lot, and it's going to affect our temperature, and it's going to actually really affect our weather and kind of affect that bigger picture for all of us. Now, heat energy is stored in the ocean in one season, and that will affect the climate almost the entire season later. So remember, everything's not like instant, and we have to wait for currents to move and wind to move and all those different things. So it could be a later delay. Oops. So just a little recap. Yeah, no, we did not do this. My bad. I'm sorry. It has the same thing, guys. I'm confused. So air temperatures around the world are regulated by movement of heat in the ocean. So most heat in the ocean is stored in the top 2 meters because seawater has a high density and high specific heat. This allows the ocean to store a lot of heat. So we're going to look at like the thermocline in a second, but remember that first couple meters, guys, is where a lot of that heat is going to be stored. The ocean can then buffer changes in temperature by storing and releasing heat, and evaporation cools the ocean down, just like how evaporation or how sweating it cools us down, which cools the atmosphere. This is more important near the equator, where there's a lot of evaporation than near the poles. So remember, where there's a lot of heat and a lot of water, you're going to have more evaporation. Hence why we have a lot of humidity in areas like the tropical rainforest. Now, in Antarctica, is there still a lot of water? Yes. But evaporation doesn't occur when it's so cold. So when we look at this, you guys remember that our temperature for a while is really consistent because this is where the sun's energy is able to get through, and we stay a pretty consistent temperature. Now, once you get past a certain degree, we drastically decrease on a steady rate. And then after that, the sun doesn't penetrate very well and it just falls off. Now, with that being said, this explains, guys, why a lot of our heat is stored in those first couple layers, because the light energy is able to keep passing through despite the density. But there's going to be a point where it's going to get too dense and too saline that's not going to be able to push through any further. Oops. Now, with our climate, there's also moving air. So there's winds causing moving air, and the surface currents help distribute heat around the globe. So, for an example, the Gulf Stream current causes the climate in Great Britain to be mild, whereas the same latitude in Canada, there would be polar bears. So if you look at like here, you look at our current here, this area is pretty mild. It has red, it's pretty warm. But if you go straight west of there, same latitude, yes, but this area is going to be really frozen. There might be polar bears in that part of Canada. So it just depends on how that wind current actually moves and how it adjusts. A change in surface currents can cause a huge change in weather patterns. So no wind equals no surface currents, or it equals different climate weather. Now, I'm sure some of us have heard of El Nino, and I'm not an expert in El Nino at all, but it's in the Pacific Ocean, and wind normally blows west, and some years it's not as strong. Now, it causes change in weather around the world, and the last summer of 12 and 18 months, from my understanding, El Nino causes a lot of rain as well, and a big temperature drop. Now, I'm not an expert in that topic by no means, but I'm sure a lot of us have actually heard of that before in some type of class. Maybe when you're like world history class or something like that, or in maybe your biology class, which means I should have taught it. Regard what I said. Okay. Now, moving on. We're going to get through 2 more slides. Actually, this is the last slide. Then we're just going to kind of talk about some last things. So, what gases dissolve in the ocean? Ocean water has many different gases dissolved into it, mostly nitrogen, oxygen, and carbon dioxide. Now, if you guys remember biology, when we talked about biogeochemical cycles, this probably should make sense because we need CO2, oxygen, and nitrogen to realistically build any organic molecule and to sustain any type of life. Now, the movement of wind over the ocean and waves agitates, mixes up the water at the surface, speeding up the exchange of gases between the ocean and the atmosphere. It's like shaking a soda bottle. So what that's trying to say is like the more agitation we have, the more easy gases can get into the water. Now, if there's no movement, there's going to just be 2 separate layers. And there's still going to be some exchange, yes. But once you shake it up, it's going to be able to mix it up a little bit easier. Now, with that being said, marine ocean plants need carbon dioxide dissolved in the water to go through photosynthesis. Now, if photosynthesis doesn't occur, those plants can't make glucose. They cannot survive. Also with that, photosynthesis releases oxygen into the water, which ocean organisms still need. So they do respiration. Now, it's not that they don't breathe oxygen. I want you guys to understand that. Because like, if you put a fish out on land, we all understand that they're going to die. They need water. Yes. But there's still oxygen in that water that they need to be able to do respiration, since that is a reactant of the respiration equation. Now, as atmospheric levels of gases rise, so do levels of the gases dissolved in ocean water. So if you guys remember back to sophomore year, you watched a video called Lethal Seas, and it kind of talks about the increase of carbon dioxide in our atmosphere and how that increase in carbon dioxide in the atmosphere actually increases the carbon dioxide in the water, which is causing the water temperature to increase, which is causing more global warming and actually causing for other organisms to die. Now, we're going to get to that, but that's kind of what they're trying to say here. And that's realistically all the notes we're going to get through for today. But I do want to talk about a couple things. So next week, I am planning assigning your final project for this class because we only have 3 weeks left. So we have to make sure we have some time to get it done. Now, for the people that haven't heard this spiel yet, your final project, guys, is going to be a multiple thing, or you can do it pretty much any way you want to. So I'm going to just pretty much give you a rubric that's going to be very generalized, but you can do things like a paper, a recorded presentation. You can do like a drawing. You can do an art project. You can do a bunch of different things. Realistically, what I want you to do is choose a topic in marine biology or in oceanography, and you're just going to go with it. I know a lot of you guys are super interested in the ocean. That's great. But in 3 weeks, I can't get through everything. And to be honest with you, I don't have the expertise to get through everything and give you guys a full education, every little piece you want to learn. So what would be cool is if we're able to just be like, okay, I'm going to figure out what I want to learn. Do your own research, guys. We have the internet for a reason. Do your own research, make your own project, and you're going to present it in some way that you would think is best for you. Now, the only reason that is that there's going to be a multitude of different ways to do this is I understand some of you guys rather write papers. Some of you guys are better at talking. Some of you guys are really artistic. But I'll make sure that rubric comes out to you guys. And then if you have any questions, you guys can ask me. Other than that, if you guys have any questions, please reach out. Other than that, guys, have a good day. Talk to you later. Bye. Where the heck's the pause button? Escape. Escape. Escape.